Android Java, live and in action. I'm Norman McEntire, founder of Servant Corporation, and for this meeting, primarily a UCSD extension instructor. So, want to show a few slides, make a few opening remarks. First of all, welcome to everyone, and thank you for being here. After all, in San Diego, there's a million other places you could be right now. So I appreciate you being here, and my promise to you is over the next few moments, you'll learn the skills we talk about related to Android faster than any method in planet Earth. And how we do that is by writing code. So I'll show a few slides to kind of set the pace and use the roadmap, but it's primarily writing code. Now, if you're brand new to Android Java, this will be a great introduction. You'll see the big picture. If you're already experienced in Android Java, then it'll be a good review, and perhaps it'll shed some new light on some of the aspects even if you're experienced. So I've broken it down into two parts. The first part, I'm going to do everything in 100% Java. I'll write Android Java, won't use any XML files. We'll talk about the architecture, the tools, things called intents, things called activities. We'll see what all those do and how they work by writing code. Then we'll take a short break, and in part two, we'll put into the picture XML. It turns out the Android architecture uses a number of XML files, and we'll see how they're used and how your Java code communicates with those Android files. And then we'll end with some whatever questions and answers may come up. Now, what you're about to see is really a short summary of what I'll be teaching at the UCSD Extension this summer. It's Android 1 programming course, and actually it's just going to start here in June, the summer session, June 29. And it's one of the times it's going to be 100% online. So you don't have to physically be there. You can be anywhere in the world. In fact, people all over the place take the course. So if you're interested in it, there are a few seats left, and you can register. The only warning is this class always fills up. I've been teaching it for several years, and every time I teach Android, it fills up. And that means people that wait to the last minute will register, and they'll say, oops, where you go on the waiting list, and it pretty much, you fall off the waiting list because nobody will give up their seat. So this is what you're going to see, essentially a sample of the course. It's actually 9 lessons, so it's a 9-week period. One lesson per week. You'll see, just like you'll see here, you'll see some slides to show some concepts. But the core part of the course, what makes it unique, is the writing of code, the live writing of code like we'll see here in just a moment. On the actual course, you also have a quiz. The quiz is really like interview questions. The idea is ask questions that you're most likely to see in an interview situation, and then have a programming assignment each week so you can practice the same skills. Here's a brief summary of the topics. It's an introduction. You learn about widgets, you learn about activities and intents, how to store things on a device, store preferences, store files, use SQLite, how to use the internet, how to play music, play videos, take pictures, how to receive broadcasts, how to write services, and also how to be a content provider. The idea is after you've taken this, you have a strong foundation in what makes an Android application. So briefly about myself, I have a BS and MS in computer engineering from the University of South Carolina. That's where the southern accent comes from. So to this day, I've been living in San Diego 15 years or more, and to this day, when I go out to a restaurant, the waiter or waitress will say, "Where are you visiting from?" Anyway, that's where it comes from. So I've been working in the computer industry what seems like forever. I've done both hardware and software design at all levels. Currently, the last few years, Android, iOS, and Linux. These are 3 key technologies that are really part of this mobile revolution that we're going through, and I focus on all three of those. For UCSD Extension, I teach Android 1, Introduction to Objective-C, iOS 1, iOS 2, and I always get the question, well, how come you're not teaching Android 2 as well? And I say, I am just waiting for the other instructor. Whenever they get tired of teaching it, I will then teach Android 2 as well, because I just love the stuff, can't get enough of it. Also the owner of Servant Corporation, which does technology training, software technology training for software technology professionals, corporate clients that want to bring up their software team in a given technology. So the question we have when we come here is, why should we cover Android Java here at this San Diego Java Users Group? And there's really two answers that come to mind. First, Android Java, the version of Android Java, is one of the most widely used versions. So as a software developer, there's a lot of projects out there. Not only projects that are for the phone and for a tablet, but it's moving into the embedded space quite heavily. So there's a lot of projects that have nothing to do with a phone or a tablet that are actually using Android Java. So that's one reason it's important to this group. The other answer is the Android Java virtual machine is the most widely run JVM anywhere. In fact, every day that goes by, there's over 1 million more of these virtual machines running because that's how many devices are activated per day. So we're talking about hundreds of thousands of Java code being executed at any given moment. So it's quite remarkable. And we all know it's just warming up. It's just warming up. So there's, as big as it is, the numbers are only getting bigger. So for the members here of the San Diego Java Users Group, knowing Android Java is a valuable part of your skill set. And in fact, my goal is when you leave this room today, if you've never seen Android Java, when you walk out the room, you'll have enough skills to at least begin knowing what it's about and even answer some of those initial questions that may come up during an interview related to Java or Android Java. So let's jump into part one. I want to use 100% Android Java. That is no XML. I'm just going to ignore the XML for this first part. We want to look at the architecture, the tools, and something called an activity. So first, the architecture. The way these systems are built, you have your hardware, you surround it with the Unix operating system. Since Unix is written in C and provides a C interface, you have C language libraries that sit on top of that. Then your Java virtual machine, in this case the Android Java version, the Dalvac virtual machine, talks to this, and on top, where our focus is the Android Java apps. So this API, this programming interface, is where when someone writes Java code in the Android world, it runs here, goes down to the VM, down to the C libraries, down to the Linux, and down to the hardware. So that's the big architecture picture. Now what development tool do you use? You use something called ADT. It's called the Android Developer Tool. It's a single bundle. Anybody in this room can download. If you haven't already, you can go to developer.android.com and use exactly what I'm using here. So if you're new to Android, you could follow this demo, particularly since it's being recorded. You could download the tools and practice the exact same skills that we're going to learn as we go through this demo. So with that said, let's actually switch over to this ADT, this Android Developer Tool. Any of you that have used Eclipse instantly recognize that this is a version of Eclipse. So Eclipse has been enhanced. They've added plugins to make it work with the Java, Android Java environment. So what I want to do is to begin a new project. And so I'm going to say File, New, and Android Application Project. Notice this is standard Eclipse. In fact, when I teach Java programming, I use the same thing and just create Java programs instead of Android Java. But with the plugins, it allows us to take advantage of the additional features of this Android version. So I figured since we're at San Diego Java Users Group, let's go ahead and create an application, SDJEG. So we see that's going to be the name of our application. There's lots of things we can set on here, but for tonight, the one I want to bring your attention to is the API levels. As a software developer, the number that's most important to you is this API number. This number increments every time the application programming interface has changed. They've put additional enhancements to that. So this gets incremented. Now a lot of people will refer to it as a version number, Android 3.0 or 3.1 or 3.2, and sometimes you'll also hear it referred to as this project name. So maybe you've heard people talk about honeycomb or ice cream sandwich or the current one, jelly bean. 3 different ways of referring to it, but you as a software developer, what's of interest to you is which API level are you targeting. In fact, notice when you build an application, you can set what's your minimum. You want to go back and also which one are you targeting. So you can be very specific on what you want to target. Let's use all the defaults and just click through here. There's a bunch of questions we could answer, but let's just take the defaults and find out what do we get, particularly from a Java source code perspective, what do we get in this project? Well, the answer is we come over here in our Project Explorer and go under the source, and I want you to observe we have a package, com.example.sdjug. This package turns out to be not only our Java package, but it's going to be the name of the process that runs. Remember our architecture level we showed? Down at the bottom, it ultimately runs on a Linux operating system, and this is actually the name of the process that will be in here. For us, we're interested in something called the main activity.java. The main activity.java. This is where you, as an application developer, begin getting involved. You extend a class called the activity. Tonight, I'm going to mention 4 classes that are very important in the architecture of Android. The first one is an activity. An activity represents the user interface that you're going to be using. And notice we have something created called the main activity. It's called main activity, and it extends this activity. Now, I'm going to delete some of this code. I want to focus on starting at the bare minimum level. On create is your first opportunity to do something. On create is when the activity is created and you can start doing whatever you need to do. What we're going to do in our case is type toast. We're going to do something called a toast. And we're going to make the text, and we're going to give the context to this, and I'm going to say, when we come into here, I'm going to say we've got the on create, and the duration, toast.length long, and show. Now a toast is an interesting user interface item because it pops up just for a few seconds. It doesn't interrupt the user's flow, and it's perfect for when we want to learn how things happen. We can see this nice little message pop up. So every time this activity gets created, we're going to see this toast appear. In fact, let's go ahead and run this. Let's click on the run button. It says you want to save the changes. Yes, I do. And it will start building this application. And once it builds it, it will run it on an emulator that I have connected up here. We'll see in a moment it start up. And watch down here on create. That's the toast on create. Notice we as the user didn't have to do anything. It just appeared and then it goes away. And in fact, we know that the activity indeed was created. Of course, we as software developers immensely think in a symmetric way. We say, well, if it's created, there must also be a way it's destroyed. And indeed there is. In fact, the activity is not only created, but it also, at some point in time, will be destroyed, and there's something called onDestroy that gets called. So onDestroy tells you, the developer, I'm done, and of course onCreate says you're just starting up. Now, the question that's sometimes interesting to pursue on this is to see exactly when does onCreate get called and when does onDestroy get called. And so to find out, what we can do is, of course, we have a toast at each of those locations. So let's start this running, knowing we have an onCreate. By the way, I'm running this on an emulator. So the emulator allows me to emulate everything I'm doing. I could also do it on an actual device. onCreate. That makes sense. But watch this. Suppose they're using your application and they decide to touch the back button. The back button. Every Android device has a back button. When I touch the back button, watch what happens. onDestroy. Your activity is actually destroyed when the user presses the back button. It says, we're done with this particular activity. We're done with it, so it gets destroyed. Now, a user may do a long press on the home key. And when you do a long press on the home key, it brings up your recently used apps. Well, I just recently used this app here, this SD Jug app, so I can touch that and watch on create. So my activity was created again. The user picked it from the recent list, but it was created because it had been destroyed. Now watch what happens if the user presses the home key. If the user presses the home key, it says, I'm just putting your application aside, but I still want to come back to it. I'm still using it. And in fact, when I do a long press on the home key and come back, notice we did not see either destroy or create when someone presses the home key. What we're actually looking at is the life cycle of an Android application. And you as an application developer will hook into the different life cycles as this moves through the life cycle and do different operations. You may save data. You may set up a network connection or take a network connection down. Now here's what's sometimes surprising with Android. Watch what happens when I rotate my device. So I'm going to press, on this case, I'm going to press the function key 11. When I rotate my device, I hope this will show, on destroy, on create. It turns out when you rotate your device on Android, the activity that you're using gets destroyed and recreated. Why is this? Well, because as you're changing the orientation of your device, the layout has to happen anew, right? The dimensions are different. And so simply by rotating the device, we see first the existing activity is destroyed, and then we'll see, so we get on destroy, on create, and we're back here. So that's sometimes surprising when you're doing an Android app. Of course, sometimes a question comes up, can you prevent it from rotating? Of course. There's all kinds of configuration settings, and one configuration setting can indeed be, say, I don't want to support rotation. I just want to always run in portrait or landscape. So you can certainly configure that, but we're seeing the default operation is an activity gets created and destroyed simply by rotating your device. Now, in the slides, as I go through, what we're talking about right now is this thing called the activity. And what you've seen, the code I've written, is inside this activity. It manages your user interface. And when you think about a mobile device, a toast is certainly something that pops up and you can see. Notice this is coming from Android.widget. In fact, when you take a course on Android, what you're really learning is the Android.whatever package. There's a lot of packages, a lot of classes, and here's one, Android.widget.toast. So you've seen, if we ended the talk right now and you walked out, the next time you see a toast appear on an Android app, you know how do you do it. It's this class, Android.widget.toast. But we know that these devices have a life cycle, which we just showed going through it, and there's actually more life cycles. There's starting and stopping and resuming, and due to time I won't show those here. In the actual course, we go through all of these so you know exactly what to do as your app's going through this life cycle. But I thought what a good one to show tonight would be the touch handling, because after all, one of the big differences between mobile devices and all these desktops is touch handling. So how do you handle touches? Well, let's find out. We're here in our activity. So I go back over to my code. I'm here in the activity, and I could say, well, I wonder if this activity has some type of method called onTouch. And in fact, it does. It says onTouch event. It turns out this gets called anytime you touch the device. You touch the screen. So we can do a switch statement, and we can say, well, let's switch on a given touch event. Let's go to the event, and let's get an action, and let's switch on that. This will tell us we touched it, we picked our hand up, we moved. There's a lot of different events here. Let's just show a few of them. If we go to motion event, and let's do a, how about, let's do on touch event, so I want to go to the motion event, and I want to do an action down. So that event occurs the moment your finger touches the screen that event will occur. Well, let's do our friend here, the toast. We know this is going to be a great way to learn how this works. So I'll say action down. And if we handle this, we can simply say return true, meaning we have handled that and we're done. Or let's do another one. How about if we say case, let's go to the motion event, and let's say action up. So if we get an action up, same type thing, we'll come down here, say toast, the action up. That means we handled it, and we'll do a return true. So I'll run my code, and what I've done now is added the capability to handle touch. So let's watch as we start up on our device. Now I want to stress again, this is exactly how the course is taught. I spend the majority of time writing code. So you follow along, you see the code described and written before your very eyes. So here we are. If I touch the screen, of course, since I'm on the desktop machine, I'll just touch the mouse. Notice it says action down, and when I lift my finger, we'll see an action up. So action down, and then action up. And of course, there's a lot of things you could do, right? You could look for the XY coordinates, you could look for all kinds of things, you can do gestures, a lot of stuff derived from that. But when we think about it, usually if you touch something, you want to see some type of feedback on the screen. So another concept, major concept related to Android, is the view. Android.view.view. Everything you see on the screen inherits from view. Everything. So that means what we should be able to do is create a view and put it on the screen. Why don't we do that? Let's say we're going to have in our code, let's have a member variable, we'll call it view. Notice the view, once again, I put my cursor over here, it comes from android.view. So that's going to be the view we're going to create. When I come into the on create, I'm going to say, okay, how about create a new view of this. This meaning for the activity. Now if I've got a view, maybe I want to set the background color, and notice the color, there's various ways you can specify it, but the most common way is simply as a 32-bit integer. You can go to the color class and you can say, well, how about make it red? Let's have a red color. And so this class will return to us a red color. We'll set that as our view. And then we're going to set the content view. In other words, the content of this is going to be the view. So this is another key concept that everything on the screen derives from a view. And we're really starting at the very bottom here, since everything's on a view. Here, everything, you can set the background color, and in fact, there we are. We see we've set the whole content to be this one view. In the world of Android, when you put things on the screen, you either put them as a single view or you put them in a group, what's called a view group. When you put things in a view group, you can have a hierarchy of layout. So the more common case, instead of using the view, like we see here, is to do the view group. But before I do that, let's give this the ability to flash on and off simply by changing our code where when we say action down, let's go to our view and let's set the background color. Let's go to color, let's choose black. So we've set it to black when we go down. And then let's do the view. Let's set the background color and set the color, let's say, back to red. Okay? So we'll set that. And now when we run this, we're actually interacting with our view. So I'll be able to say, well, I start with a red, and as I come up here with the red, I will touch my screen. So here's my red. I touch the screen, it goes black. I release, it goes red. So I've got this feedback, red, black, red, black. But, you know, it would really be nice if we put some other controls on here. I said when you look at the Android architecture, Everything on the screen is a view or a view group. A view group being a group of views. So why don't we replace this view that we've got with another concept called a view group. So what I'm going to do is I will take this code I just wrote related to the view. I'm going to comment that out and comment this out. And I will say, let's get rid of this. And let's instead use a view group, and there's lots of view groups, but I'm going to choose a linear layout, something called a linear layout. I'll just say, call it LL, equals a new linear layout. And this linear layout will be of my context. And why don't we take our linear layout, since it is also a view, we can do the exact same thing we did with a view, and that is we could set the background color to some color, and let's do it a little bit differently. Let's have an integer color, and let's set it by going to the red. Actually, let's do alpha, red, green, and blue. What's nice about this, it shows the true way you can manage colors in Android. We're all familiar with red, green, blue. That's pretty obvious. Red, green, blue, turn it on, 0 to 255. The alpha setting is how transparent it is. It can either be fully transparent or fully opaque. And you can control that by this value called alpha. So in my case, let's say I want to make it fully opaque. I'll say 255. Let's turn off the red. Let's go for the green this time, maybe 255, and blue. So that'll be the color of our linear layout. A linear layout, though, also has the ability to set the orientation of how it lays out things on the screen. You can either lay out things vertically or horizontally. So let's say we want to lay them out vertically. So I'll say go to the linear layout, and let's do a vertical layout for that. And let's make this our new content view. So I'll come here to the content view and put now the linear layout. And notice when I run this, at this point, I should have a green layout. Of course, nothing's in it yet, but we should see that we've got a green place there to put our layout. Let's see what happens. There it is. Now keep in mind, this is a view, but it's a view group. And by definition, you can put things inside the group. Let's put some text on here. There's a control called a text view. And so basically the text view is how you can display text on the screen. So what we're going to do with our text view is as follows. We're going to say, well, let's come up here and let's add to our design a text view. Let's call it text view. Notice that text view is also a widget. It comes from Android.widget. And so when we come down to here, let's, since we've already got a linear layout, let's create a text view. So text view equals a new text view of this. And the text view, we can also, since it's a view, we could set its background color. And let's choose, how about color? Oh, let's make this one yellow as its background. But a text view also has text. So we could say, all right, let's have text view. Let's set the text to say, how about hello, Android Java. Do that. But we want to put this text inside this linear layout. So to do that, we need to specify the width of this thing. And we can specify the width by going to the linear layout, going to something called the layout parameters, and there's a layout parameter called match the parent. In other words, whatever width the parent has, you have the same width. We can also have a height. So if we have the height going to our linear layout, going to the layout params, and this one we're going to say wrap the content, only be as wide as need or as high as needed. So now I can say go to my linear layout and let's add a view, and the view we're going to add is going to be the text view. Let's make it that width and that height, and let's find out what happens now. You should be observing, we're doing all this in Java code, and keep that in mind because after the break, I'm going to repeat this demo using XML and Java together. And you'll see that some of the steps we're doing, we can also do in XML. What we see here, look at that. Here's our layout, the linear layout, and up at the top, hello, Android Java. We see we've got a text field right there, and it's been laid out here in this linear manner. We're almost done here before we take a break, but let me add maybe a button. We all like to see a button, so let's have a button equals a new button of this. And we take this button and let's set the text. Let's say, how about touch me? And maybe this button, let's set, since it's also a view, let's set its background color. Oh, let's choose another color here. And the thing about a button, we need to touch it and have it do something. So that means we need to have a listener. One of the key concepts in Android is widgets can have listeners, so when they do things, they call you back. So in this case, I'm going to say set the onClick listener, and I'm going to use an anonymous inner class. So here I'll have an anonymous inner class that will handle this click event. In other words, when I touch the button, it's going to create a new class for me, this anonymous class, which is an on-click listener. And what I will do is what we've been doing all evening long. I'll just display a toast and say that touch here, or I'll say button touched. Now, one of the reasons I like writing code live as opposed to just showing slides is you're constantly running into issues that for a beginner, when you're first writing code, they can be real puzzling. And this is a good example of that. I've used toast make text several times, and it worked every time. And now I pasted it here, and I've got an error. And you look at this, you put your cursor on it, and you're trying to read it, and you say, well, this method, make text, and gives the prototype, and the type is not applicable for the arguments. And you know, you look at your arguments, you say, I've been doing this the whole time, how come it's not working now? Well, for a beginner just learning Android, this can be a tough one, but here, it turns out that the value of this is the this of the anonymous inner class. We don't want this for the anonymous inner class, we want this of the activity. So we need to qualify it and say main activity, the main activity dot this. And then of course the error goes away. So there's tremendous value in taking the course, watching the code being written, seeing the issues that occur, and fixing them here on the fly. So now when we run our code, not only, oops, I forgot to add the button to our layout. Well, let's see, I get so excited sometimes I forget to do that. So I'm going to take my linear layout and I'm going to say, how about add a view? And let's go, we want to add the view. This time it's going to be the button. We'll use the same width and height for that. And let's run this. And let's see what we got here. Keep in mind the linear layout, and then inside the linear layout, we'll have the text view widget, and then we have the button widget. And if I touch the button, go boom, we see, the button was touched. So we've got some feedback. So at this point in the course, you've seen, interesting enough, the concepts I've shown you, everything else is just more, right? There's more widgets, but they're either you write to them like we did the text view, or you listen to them like we did the button. There's one other major concept though before we take our break, and that is something called an intent. An intent is how you do late time binding in Android. An intent allows you to send essentially a message and says, I want to do something, I have the intent to do something, and it goes out, it finds who can do it, and it does it at runtime, not at compile time. This concept, android.content.intent, is a major concept, In fact, let me demonstrate. Suppose we're writing this code, and when I touch the button, what I want to do is display the phone dialer. Well, I've written my code here. The phone dialer was written by somebody else. At runtime, how can I connect them together? The answer is by using an intent. So I'll come in here and I'll say, well, when we touch this, let's create a new intent. So we'll create a new intent. An intent is just a message. In fact, first let me resolve it here. It says, hey, what's this? Notice it comes from android.content. So android.content. So I've got my intent. I'm going to set the action that I want to occur. Notice an action is simply a string, and I'm going to happen to use intent.actionDial. So intent action dial. There's lots of different intents. And then I'm going to say start an activity using this intent. So start activity with the intent. Remember, we are already in our activity, our main activity. I'm going to have the intent to start another activity. What? The action dial. So here we go. Let's run this. So suppose part of your application, you wanted to have it where you touch this button and you can immediately call customer service on the phone. Well, by having this feature, you can have the intent. Get back over to here. I can say touch me, and instead of popping up the touch me message, watch this. We are switching to another activity, a totally separate activity. This activity is in a separate process space, totally separate. We use the activity. To the user's viewpoint, it looks just like something you've used, right? It's like it's part of your application. When they're done with it, they touch the back button. And we know the back button destroys the activity and goes back to this. And then they could say, well, we're done with this part one of the demo, so let's do a back button on it. We know we get our destroy pop up, our activity is destroyed, and everything is back to normal. And in fact, this brings us to the end of part one of this demo. We did nothing but write Android code, the Android Java. You saw the architecture, the developer tool in action. You saw what an activity is. That's one of the key things, right? Believe me, if you start the interview and you ask the Android developer, what is an activity? And they go, you know that's probably not the right person for the job. So activity is one of the key ones. The toast is important. Handling touch events, the view, the text view, the button, and the intent. You saw all these live and in action. What we're going to do after a break, we'll take a short 10-minute break. When we'll start back at 8 o'clock, top of the hour. We will, I'm going to redo this, but I'm going to use a combination of XML and Java. You'll see that a lot of the stuff we do, you can do by using XML. I'll also show how you can add a service, add a content provider, and add a broadcast receiver, as well as another activity to this particular project. Before we end this part one, are there any questions on part one? Yes?
Question right there, the on-click, that's the on-click method?
Yes.
Where does that get called in your code, or is that just something that happens when you press the button?
Great question. So the question is being, how does this get called? How does this on-touch event get called? There's actually a chain of events that occur. When you touch it, the first person that has the option of responding to it is the view. So the view itself can actually capture that and not pass it on any further. But in this particular application, the view doesn't handle it. It just passes on up, and it goes up to the activity. So the activity gets the option to handle the touch event. So it's actually a method that's a part of the activity. So you get it by default. It gets called anytime someone touches the device.
So the follow-up is that the same thing that happens when the on-click method you had?
That's correct. That's correct. It's very similar to that. The difference is, in fact, this is a great comparison. The button is actually handling inside if you could look at the button code inside of it, it's handling this when you touch the button. Let me get the one in the back. And then I'll
Have you done anything with I think it's called Android Studio?
I have not used Android Studio. I do all, there's a number of Android tools out there. I do all of my work with the Eclipse. It was the original tool, and plus I use Eclipse for other Java projects. So I tend to just stick with it because I've used it ever since I started teaching Java long ago, and the Android plugins work nice with it. Is there a question?
The whole anonymous interface, I didn't appreciate it. Why is that being used?
Yeah, the reason I use the anonymous, so the question is, this anonymous interface, why did I implement it like this? Because it turns out there's an alternative way I could have implemented it. So the question is, why did I do it like this? I wanted to do it to show the Java developers that the use of anonymous inner classes is something you'll use, or you see used quite frequently in the world of Android. Just to show an alternative way I could have implemented this, let me show an alternative way. Because this is really cool too. Let's say instead of implementing this as an anonymous inner class, I decided to do it like this. Set on-click listener, and instead of putting an anonymous class, I'm going to say, I want this class. I want the activity to handle this. Now here's why I like doing this demo, and I'm so glad you asked about it. Notice I've got an error at this point. Well, the error, when I put my cursor over here and I look at the error, this is one of the cool things about it. Not only does it give me an error, but it suggests these fixes. Now normally, the first fix is what you want, sometimes the second fix, sometimes even the third. In other words, if you go down here. This one, it turns out is the last choice. You got to go all the way down. Let me get this here. We got to go. I'll pause. I'll go down to the end and say, give me the very last suggestion is let main activity implement on-click listener. Let it implement it. I say, okay, that sounds like a good fix. So I click on this, boom, and notice it adds to my code, implements on-click listener. So now the main activity implements this. But now I've got another error. It's kind of like the balloon problem, right? You push it here and then now, no, what now? Well, again, this Eclipse environment, I put my cursor here and it says, let me suggest I can add the unimplemented methods. Well, yeah, I think that's a good idea. So I will say, yep, go ahead and add the unimplemented methods. And you know what? If I look down here at my code, it added this method right here. And I always tell my students, in the world of software, you don't believe anything until you see it run, right? I mean, you don't believe the source code until you see it run. So does this really work? Well, we can say intent. Let's have intent equals a new intent. And let's say, in fact, let's even do the shorthand, intent dot action. We'll do a dial. And then we'll say, how about start the activity using this intent. This is the same code, but instead of using an anonymous inner class, I'm saying I want main activity to implement that. Let's see if we've successfully implemented the same. While it's building and running, let's compare and contrast. The advantage of the first way is I didn't have to scroll my code. I could see everything that was being handled with the button right there. Right? I could look at both the button and the handler. The anonymous inner class, all the code is right there. My second way, I had to scroll down, find where this other method is at. But from a user's perspective, when you touch it, it's the same results. Either way, whether you use the anonymous class or the other. Let's take a short break. We'll use, take 5 minutes. We'll start back 5 minutes from now and do part 2 of this. So stretch, do whatever you can.